So we're going to continue talking about graphs and polynomials. We're going to review the term multiplicity, which basically is describing how many times this specific zero appears in the set. So for instance, if my graph looks like this, it kind of lingers around a point, we consider that to be a snake. That's a nickname. So that point is going to have a multiplicity of 3. So say, for instance, this was -1. I could write it in my set as -1 multiplicity of 3, which means the same thing as -1, comma, -1, comma, -1. Same thing when your graph looks like this. If the graph is going down and it touches a point and it bounces off, that point will be represented by a multiplicity of 2. So, for instance, if this was 3, again, it would be 3 multiplicity 2, or you could say 3 comma 3. It's kind of like when you're adding versus multiplying. If you had 2 plus 2 plus 2 plus 2, it would make more sense to just say 2 times 4. It's kind of along those lines. And then if your graph is just going straight through the point, then it's going to be multiplicity of 1. So that's important to know because we're going to try to write the zeros in factored form. So we need to know how many zeros that we're working with. Something else you need to know is how to determine your leading coefficient. So I've created a little chart here. So leading coefficient, if it's positive versus if it's negative, and then also if the degree is going to be an even degree, say for instance like x to the 6th power versus an odd degree, x to the 3rd power. So what you are looking for, if it is positive, is that your arrows, your end behavior, you're focused on the arrows, are pointing up. So think of a smiley face. When I'm smiling, I'm positive, so that's going to be a positive sign. Well, what if you have a case where one of the arrows is pointing down and the other one is pointing up? So again, my end behavior, what happens at the end? So I start my graph from left to right, and anything can happen in the middle. And I end up positive. I'm going up. So these are the two cases where my graph's leading coefficient will be positive. Now, the opposite happens for negative leading coefficient. If my arrowheads are pointing down, that means I'm frowning or I'm negative, I'm sad. So that's why it's a negative sign here. Same thing with this one. It starts off up, but then all of a sudden, anything can happen in the middle, I'm down. So the main part of the graph that you want to look at is the very end. What happened at the end? At the end, I was going up. At the end, I was going down. Up, down. So now the difference between even and odd is both directions are pointing in the same direction. So that means it's even. If the arrows are pointed in different directions, that's odd. So think of like if a person or people are at odds against each other. One person's thinking one way, one person's thinking the other way. So that's how you can remember odd. And again, positive and negative is based on what your leading coefficient will be. So let's take that information and we're going to try to write this in a factored form. So in order to write it in factored form, we want to make sure that we know what our zeros are. So that's what we're going to do. We're going to highlight our x-axis because our x-axis is where our zeros are going to come from, our real numbers anyway. So you can see the little points there. I went ahead and wrote the numbers down in case you couldn't see that. So the units are counting by ones. All right, so I have a -1 right here. So I'm going to write that down as -1 with a multiplicity. And now this is where what I was talking about earlier comes into place. This graph is going down, it touches and it bounces off. So if I am bouncing, my multiplicity is going to automatically have the rule that is 2. So we got to keep up with this. If I were you, I would take notes and just have a little sheet next to me as I am going through trying to determine my multiplicity. So my multiplicity, when it bounces, is going to be 2. That's just going to be the rule all the time. This time, my graph is just going straight through. It's going through straight point, the point 1. So 1, multiplicity 1. So this first number represents my zeros. And the second number represents what my actual degree will be of this graph. Okay, so now my final 0 that's shown here has that snake. So these are my only 3 options. It's either going to go straight through, which means it's a multiplicity of 1. It's going to bounce, which means it's a multiplicity of 2. Or it's going to have that little curve, a slight curve, which we call a snake. So this one is going to have a multiplicity of 3. So if I'm trying to determine, well, what is the degree of this entire graph? Again, you can't see the complete picture here, but if you could see the complete picture of this graph, I'm just going to try to draw it in as best I can. There's going to be a curve right here. So if you're counting your curves, that will help you in determining what your degree is going to be. I can also count it here. So 2 plus 1 plus 3 is going to be 6. So let's see if it's going to be x to the 6th power. Another way that you can tell is by how many turning points it has, and then you add 1 to that. So I start reading my graph from left to right always. So I'm going down, I turn once, I turn twice, I turn 3 times, I turn slightly here 4, I turn again 5, and then you have to add 1, because if you recall, if your arrows are in the same direction, that means you're going to have an even function. So that means also that my degree has to be an even number. So this is going to be the function of f of x is equal to, and then what you want to do is you want to take your zeros and put them in factored form. Before you do that, pay attention to whether or not your leading coefficient is going to be a positive or a negative. Since the arrows are pointing upward, that means like you're smiling, so you're positive. You don't have to write the plus sign, but I do it just to keep track. Then I'm going to start with my highest degree, which is based off of this multiplicity. So I'm going to take this one and I'm going to write x, change the sign to -3, raise it to this degree, which is the 3rd power. Going in order, standard form, I'm going to take x, change this sign, raise it to the 2nd power. And then lastly, I'm going to take x, change this sign. You don't have to write the 1, but it's raised to the 1st power. If I know that this is in fact x to the 6th power, my exponent should add 2 equals 6. 3 plus 2 is 5, 5 plus 1 is 6. So that's one thing I want to check. The next thing I want to check is that my leading coefficient is in fact positive. And again, I'm looking at both arrows were going in the same direction. I know it was even, and it's also positive. So I'm on the right track with that. And then the last thing I want to check is I want to make sure that I did change those signs. So if I were to substitute my zeros in for x, my factor should become 0. So for +3, if I put that here, 3 minus 3 is 0. And then if I were to take this one, -1 plus 1 is 0. And then finally this one, 1 minus 1 is 0. This is my answer when it's in factored form. You do not multiply it out. So make sure you understand when you see the directions factored, you're going to have parentheses in your answer. So now you do the exact same thing for this type graph. This is my x-axis. I'm highlighting it. And the first thing I'm going to look for are my zeros. I see I have a 0 at -1, and it's going to have a multiplicity of 2. How do I know that? Because it has a bounce. It touches it and it bounces off. So that's going to be multiplicity of 2. The first number I'm writing is 0. The second number represents my degree. Going across, I have a 2. 2 has a multiplicity of 3. How do I know that? Because it's a snake. Snake has the rule that it's going to have a multiplicity of 3. So those were the only 2 zeros that I saw on my x-axis. If I understand how to determine what type of degree this is by using my turning point, I can do that and verify that 2 plus 3 is going to in fact give me the 5th degree. So I just want to verify it. I'm starting from left to right when I'm reading my graph. I turn once, turn twice, turn slightly 3 times, turn 4 times, and then I add 1. So 4 plus 1 is 5. This is a positive x to the 5th type graph. So I'm going to go ahead and I'm going to write my function out using f of x or y. Sometimes you'll see y. Again, I don't have to write the plus sign, but I'm going to write the plus sign just to remind myself that this is a positive leading coefficient. The second thing I'm going to do is put it in factored form based off of the highest degree. So my highest degree is 3. I'm going to change my 0 sign and I'm going to raise it to this degree. And now I'm going to do the same for the next one, which is x plus 1 this time. Raise it to the 2nd degree. If I'm doing this correctly, 3 plus 2 will in fact give me my highest degree. I know it's positive because again, my end behavior is pointing upward, so that's positive. And if I were to substitute my zeros in for my x values, I should end up with 0. So positive 2 minus 2 is 0. Negative 1 plus 1 equals 0. So this is how you determine your multiplicity and also how you put it in factor form. I think that was pretty easy. What do you guys think? Okay.